harmonic type force is a motor. When your motor is rotating, your wheel will also rotate. This is the concept of rotation. This is called harmonic motion. What do you mean by that? If any action in this universe, if you are viewing, if it is going to and fro, if you are moving 2 step forward and 2 step backward, if you are constantly doing that, you are doing what kind of motion? Harmonic motion. So this could be applied in linear, or you can take it as a circular also. Can you see the relation between circular and linear motion? You try to connect a rod. You put a straight rod here and tie a rope. And if you try to rotate, the bottom rod will move up and down. So you connect with this lever and imagine. Have you seen wiper? The wiper blades in all the car will be moving up and down. So how it is moving up and down? Below the wiper you have a nut. So this nut will be moving in rotational mode. Have you seen that? If it is moving in rotational mode, it will be created into linear mode of action. So all the rotational mode can be made into linear action. Linear to rotational action can be done. So if it is going to and fro, it is called what kind of vibration? Forced harmonic vibration. This is the mathematical form. In the last class I have said that all the physical work has some mathematical equation. The fan is rotating in harmonic motion or not? Yes, the fan is rotating in harmonic motion. Why? Because it is doing the same work in a particular point of time. And what is non-harmonic motion? Can you imagine wind? Is wind force a harmonic or non-harmonic? Wind will blow according to its time. In the afternoon you have less wind, but in the evening you might see a high wind. So the wind blow is not harmonic. It can vary with the time. And earthquake force. Is earthquake continuously having the same shaking? No, it will increase intensity and it can reduce. So it is non-harmonic. That has a separate equation. So you have the harmonic equation called F sine omega t. Why the sine force is introduced here? Sine, I have said you in the last class. What do you mean by sine? You can plot the sine in terms of a wave. Yes or no? Sine 0 is what? 0. Sine 30 is what? 0.5. Sine 90 is 1. Sine 120. 0.86. Sine 135. 0.7. Then it is reduced. Sine 150. 0.5. Sine 30 is 0.5. Sine 150 is also 0.5. What is sine 180? 0. So sine 0 is 0. Sine 180 is 0. Sine 210 minus. What it is happening? It is like a wave. Up to sine 90 it is going up. Then after sine 180 it is going to neutral position. Now after 180 if you provide 210 it will go negative. Now try 240 minus 0.8. So it goes in negative mode. At sine 360 you put sine 360 0. So what happens? Sine 0 to 360 is a single oscillation. You can write all the harmonic waves in terms of what function? Sine or cos function. So cos is also similar. Cos 0, 90. It will start from 90 to 0 and 90. So it will be like a wave. So this is what I would like to highlight. The vibration can be written in terms of equations. In the previous problem, you would have not have this single degree of freedom system, free vibration. There you don't have this component. What is this component? Force component. While solving the free vibration problem, you have this component mx double dot plus kx equal to 0 was the solution for free vibration. But in the forced vibration, you can see F sine omega t. M mass, x double dot is acceleration. What is k? Stiffness. What is x? Displacement. So all the components are known. What do you mean by F here is force, and omega. Do you know omega is known as frequency? If omega n is given, what do you mean by that? Natural frequency. There is two difference. What do you mean by omega n is natural frequency? What is omega? Frequency. These are the two differences. Okay. T is known as what? Time. at 3 second, what was your rotation? You can find with that. If you divide this equation by m, you have this equation, divide the whole equation by m. What will happen if you divide m by m? Here it will get cancelled. K by m. What is k by m? Omega n equal to root of k by m. If you take root outside, what it will become? Square. So you can write x double dot plus omega square equal to f by m sin omega mt. This is your next step of equation. Now rearranging the above equation, you can write this wonderful equation. This is called the response of forced vibration system. If you are going to MTech, you will be learning the derivation for this. F you know force, K is known as stiffness. But what is beta? Here another new term introduced called beta. What do you mean by that? Beta is known as frequency ratio. Omega by omega n. Omega is frequency, external frequency, and omega n is natural frequency. If you divide these two, if your value is 1, then it is called resonance. If earthquake frequency and your building frequency matches, what will happen? Resonance will happen. What? Abnormal vibration. Can you recollect this? Why only one spring is been oscillating too much? The rest of the springs are not oscillating like that. What do you mean by resonance? Is abnormal oscillation. Why only one system is oscillating? The same way, there might be building of single story, 2 story, 3 story like that. In a place, if you are looking only this Kumbalgod area, you have different height of buildings. In an earthquake, only one building or 2 building can fail. The earthquake wave and their building natural frequency got equal. If it is equal, what happens? Resonance being created and only one building gets too much vibration. If you are living in a hut, whatever might be your earthquake, you will not experience the devastatingness of that. If you are visiting in 50th floor in a building, then earthquake is severe to you. It will affect you. You can see the vibration. If you are visiting in tallest part in a building, even small vibration affects you. If you are in ground floor, vibrations will not affect you. When you are designing your structure, you should keep in mind that earthquake force should not affect my building. So what to do? It should be far away from the resonance. Attending the meeting is also an important part as an engineer. They will be a 15-year-old experienced engineer. They will be 30-year-old experienced engineer. You will be a fresher. They will be speaking something. At least you should know what they are speaking. In a meeting, if you are sitting simply and they will ask, tell about this case. Tell about your solution, they might ask. What you will tell at that point of time? Sir, I completely agree on you. This is the only answer you can give it. Response spectrum, it is a graph. In a graph, you have 2 axes. What are they? X and Y axis. So the X axis should be frequency or period. Your Y axis is the response of your structure. You have the response spectrum graph here. A response spectrum is a function of frequency or time period showing the peak response of simple harmonic oscillator that is subjected to transient event. Horizontal force. Transient is horizontal force. What makes your building to move horizontally? Earthquake, wind make a structure to move horizontally. The response spectrum is a function of natural frequency of an oscillator to the structural response. The response might be acceleration, velocity or displacement. And this is a graph showing the response spectrum of a structure. This structure might be 3 floor. The 3 floor fundamental frequency is given here. By this response spectrum graph, you can use it for your building and you can protect your building against earthquake. Characteristics of response spectrum. Right now you know response spectrum is a graph. And what are the characteristics? For India, you have response spectrum graph. If you are going for Sri Lanka, you have different response spectrum graph. This graph is not common for all. If you are having stress strain graph, have you heard about stress strain graph? Stress strain of a mild steel. This is common if you test in India, and if you go to United States, stress strain graph is same. It will not get changed. But response spectrum graph changes according to region. It is created for a particular region. So how the graphs are being formed is by taking historical earthquake. These are the historical earthquakes in India. You can see all the bubbles are shown here as an earthquake. In which state you had most of the earthquake? Where you can see the cluster of bubbles. In Assam, Meghalaya, Nagaland region have frequent earthquakes. You can see number of earthquakes are being struck here. And can you see here? They collect all these earthquakes in past. In 150 years, what are the earthquakes occurred in India? They take all these parameters and they take geological effect. India has different types of geology. In Himalayan region, you have alluvial soil. The geology is different. And Indo-Gangetic region, you have different soil. In Deccan Plateau region, we are here in Deccan Plateau. You go further, southern side, you have red soil, you have different lithological features. So, for all the lithological features, a combined graph is being formed. If a dam is being collapsed, it will affect all the villages. Making a dam or constructing dam, you should draw the separate response spectral graph. Okay, which shows likely maximum response spectral value to experience in the regions. This is the graph you can see in IS 1893. X-axis is frequency or period. So here you have the period here. This natural period, and what is this? SA by G is known as acceleration. So in your earthquake codebook IS 1893, they have given this graph. If you want to make earthquake resistant structure, take this graph and design your building. You have to find natural frequency of your building respective acceleration. Calculating the maximum response for a range of values of frequency damping. Two parameters are being added. Damping for 0.05. This graph is for damping 0.05, and if you increase more damping, the structure will not vibrate. Then plotting the result graphically to get the response spectral graph. There are two methods to design earthquake resistant structure. One is equivalent lateral load method. In third module you will study that. Second method is response spectral method. This is the most effective method you can use for any earthquake analysis. It shows you the maximum possible way your building can oscillate. By using this graph you can check and you can find the maximum value for your building. This chart shows you that maximum response of all possible single degree of freedom system to that component of earthquake. This y-axis is called response. This can be either acceleration, velocity or displacement. Okay, by this graph what you can understand is, if you are building earthquake resistant structure, your building has a natural frequency of 0.5. So this is starting from 0, 1, 2, 3, 4, 5, 6. So where you have peak value of acceleration is between the value 0.5 to 0.2. Around this region has your maximum value of earthquake. So by this graph what you can understand is, if your building does not fall under this natural period, then your building is safe against any earthquake. This is given for three type of soil. If your soil 1 is rock, type 2 soil is medium, type 3 is soft soil. So this is rock soil. If you are having a rock soil, you can use this curve, thicker curve, and much lighter you have medium soil, and for soft soil you can use this response spectra. These are the respective values. How you can find your soil is rock or not? If you have studied geotechnical engineering, SPT, standard penetration test, Have you heard about that? Yes. If you are doing that test, you can classify your soil into three types: rock soil, medium soil, or soft soil. Okay. When doing the SPT test, how you will write the result? N values. What is N? How many number of blows you have done? That much of N value. So the result of SPT test will be in terms of N. If your N value is very less, that is below 15, the guideline says that what do you mean by N is you are blowing the hammer, you are blowing with the hammer. If it is penetrating quickly, then your soil is hard or soft? Soft, exactly. If you are blowing it continuous period of time for 30 seconds and if your penetration is very less, then it is called a good soil, and you have the classification. How to classify to hard, soft and medium. So in earthquake code book you have the classification. So by that you can classify what is your type of soil.